Okay, so welcome Jesper, Nicole, and Pieter.
Thank you for that. So welcome. It's a pleasure to see so many of your smiley faces here, and thanks for letting us enjoy all your presentations as well. It's been a pleasure to watch. We're happy that you're here to watch us now. We're going to talk about planetary boundaries and sustainability principles, an integrated approach in the context of agriculture. A little bit of what we're going to go through. We'll start with a little bit of background, just explaining why we think what we've done is relevant in the context that we're all in. Go over our methods, move into results, discuss our findings, and bring a little bit of additional stuff that we found ourselves, and then sum up and conclude some of that. So to contextualize a little bit of this, obviously we have this great thing called the Sustainability Challenge that's been elaborated all too well over the past couple of days. But basically since the Industrial Revolution, it means the socio-economic trends have altered the state and functioning of the Earth's systems. And are continuing to do so with increasingly negative consequences. It's an inherently complex challenge in the way that it depicts this interplay between all the social and ecological systems. The increase in global population are applying severe pressures on the Earth system, resulting in issues such as climate change and loss of biodiversity. This in turn lowers the planet's capacity to deliver the necessary ecosystem services that we need as a society to be able to support ourselves. Also, it compromises the resilience of the entire system, so its adaptive capacity to deal with any abrupt changes that might occur in the system. So consequently, all these pressures applied on the Earth system means that we move closer and closer to a state of increased uncertainty. There we go. So there's plenty of frameworks addressing this challenge that have been developed to kind of assess or deal with all this complexity and the challenge that's ahead of us. And we've chosen two of them for our research, so Planetary Boundaries and Sustainability, the FSSD, sorry. Within the Planetary Boundaries, we can say that it was developed at the Stockholm Resilience Center and first published in 2009 with a revised and updated version coming out in 2015. And it basically depicts anthropogenic pressures on the Earth system and describe how we move from what they refer to as the state of the Holocene, which is a state that's similar to what's within the safe operating space and where the Earth is somewhat in a predictable and stable state, where we can thrive good as humanity. And then moving us to the era of the Anthropocene, which is basically where we are now, which is an era where humanity is the main driving force for altering any activities within the Earth system. And it depicts 9 Earth system processes, 6 of which, or 6.5 of which are quantified currently. It operates with these various spaces, so there's this space called the safe operating space, which is the space in which the Earth can support humanity stably. Then there's the zone of uncertainty, that's where we move into the bit of the yellow bits here, in which there's an increased uncertainty and risk of tipping points. And if we move beyond the zone of uncertainty, so what's depicted as red here, it's getting quite dangerous, and that's where we further increase the risk of tipping points, and which can result in the triggering of non-linear and abrupt environmental change that can be deleterious or even catastrophic. The other framework, we're a bit more familiar with this, the Framework for Strategic Sustainable Development, FSSD. So through an enhanced understanding of system and success, it offers a stepwise guidance towards sustainability for the society. It works with a principle-based definition of sustainability bound by the 8 sustainability principles. So the 3 ecological, governing society's interaction with the biosphere, and the 5 social, governing the societal structures in which we operate as humanity. Our research in this area addresses aspects of each framework, so we're not addressing both of them in full. We're taking the individual 9 Earth system processes, so the actual planetary boundaries from the PBF, as we refer to, and then we're dealing with the sustainability principles from the FSSD. And why are we doing this research? Well, first of all, we find it very, very intriguing. It's an interesting subject, but there was also an invitation from the field. So back in 2013, Karl-Henrik and Göran and a fellow called George Basily, I hope I pronounced his surname correctly, mentioned in a paper called Analyzing the Concept of Planetary Boundary from a Strategic Sustainability Perspective, where they mentioned that a combined research and application approach is needed, referring to these two frameworks. And building on that, in January this year at the Stepwise conference in Stockholm, Johan Rockström gave a lecture where he spoke to the same potential for integration. And we're just going to show you a brief video with him speaking about that to bring some context to it. And in the beginning of this video, he refers to the planetary boundaries as not being an operational plan on the ground.
It's not an operational plan on the ground. And that's where my and many scientists' excitement comes up with the remarkable, fantastic work done by the framework on the strategic framework on sustainable development that we'll be discussing here today, and the progress made over the years on getting the sustainability principles operationalized at that level where it really means something to concrete business, communities, households, cities, and that now is the chance for the first time to connect the global with the whole FSSD framework and really translate that operationally so we can start this journey of grand transformation, because we only have 2-3 decades on our timeline to transition into a safe operating space, giving us this good future without dramatic invoices.
So these two invitations inspired us to take upon us this research. So again, trying to implement an integration and application approach of the sustainability principles and the planetary boundaries. Now, in order to do that and to define what are we going to apply this on, we needed some sort of context. And we identified agriculture as an applicable context for a number of reasons. So we chose it as our case context. Well, why agriculture? Agriculture is a system we have relied on for the last 10,000 years to support humanity. And it is a very important system to us all. It has been able to feed the growing population, but of course also with negative consequences. This slide shows how currently 40% of all land is used to produce food. Some of these consequences are the expansion of arable land, such as cropland and pasture, into natural vegetated areas, such as tropical rainforest, which have impacts of degradation both of these biospheres as well as then of the soil later on. On existing farmland, we've intensified through the use of fertilizers and pesticides, the use of mechanization and irrigation, and some of the negative consequences of that are issues such as eutrophication, a local example here in the Baltic Sea, which I'll get back to later. Now, what really convinced us that this system would be applicable was assessing it from the perspective of the planetary boundaries, and looking at how does agriculture fit into these. And in this slide, you see how the blue sort of displays the relative contribution of agriculture to these transgressions. This information emerged out of our literature review and just shows sort of visually that agriculture has a huge impact on these different boundaries that have been transgressed, and that really convinced us, okay, because of this and the very strong intimate relationship with the social system, this would be a complex and applicable system for us to apply this integration on.
Thank you, Peter. That brings me to our research questions. So the primary research question of our thesis is how do the planetary boundaries and the FSSD sustainability principles intersect and provide additive value in the context of agriculture? And this leads us into our secondary question, that is, how can an integrated approach of the sustainability principles and the planetary boundaries be used in practice? And as we've spoken to, our scope is very specific. We are looking at the planetary boundaries, which are nested within the Planetary Boundary Framework, and as they overlap with the sustainability principles, which we acknowledge are nested within the Framework for Strategic Sustainable Development. And all of this we're looking through the case context of agriculture, as Peter just explained. And I'd also like to highlight that our intended audience for this research are any sustainability practitioners who would be interested in such a novel approach of this integration. So advisors, policymakers, consultants, and the like. So how did we go about doing this? Well, we decided to use a pragmatic qualitative research approach, and we broke that out into 2 phases. So we started our phase 1 with developing and populating a matrix. And following that, we entered into phase 2, wherein we interviewed 8 sustainability experts in the field. So in phase 1, we started with an extensive literature review, which fell right into our matrix development, so our preliminary matrix. We populated this matrix through our data collected through the literature review, as well as our own understanding of how agriculture contributes to the SP violations and planetary boundary transgressions. This initial matrix went through a period of validation where we used additional literature review to check our understanding. And following this, we did some more interpretation, which led into a redesign of our final matrix. Within phase 2, we had our qualitative semi-structured interviews. So before we began, we needed to create a criteria of how we would select our interviewees. And we decided that everyone we interviewed needed to have a basic understanding of an agricultural system. They should have experience using the Framework for Strategic Sustainable Development and/or the Planetary Boundary Framework, and they should also have expertise within the area of sustainable development. So we conducted the interviews, and the majority of us were present for each interview. Immediately following, we transcribed verbatim. Following that, we did our first round of thematic analysis, wherein we used open coding and came across 12 main themes. These themes fed directly into our second round of thematic analysis, wherein we used a priori coding. At this point, collectively, we clustered and merged certain themes and had a discussion around this. Then we did some more interpretation and data analysis. And finally, to ensure further validity, we sent out our results to all of our interviewees to just double check what's called member checking, to ensure that we had properly interpreted their statements. So in developing the matrix, as we've alluded to, we looked at the 9 planetary boundaries and their intersection with the 8 sustainability principles. And quite literally, we integrated them into a matrix populated with our literature review. Quite quickly, we realized that the social sustainability principles were very difficult to apply on a framework such as this. And we acknowledge that the transgression of many planetary boundaries, as well as the violation of ecological sustainability principles, do negatively impact the social system. However, structural obstacles to the fulfillment of human needs that have root causes within the ecological system do not belong with the social principles. And what I mean by that, or a good way to understand it, is if you think about climate change, a negative impact of climate change could be a severe drought, which could obviously impact human health. However, that may not be driven by a structural obstacle within society. And a good way to understand this is using this image. So seeing society as internally governed by SPs 4 to 8, whereas the ecosystem is governed by SPs 1 to 3.
So to give you some examples of what we found in this process, to take the first planetary boundary of the biogeochemical flow of nitrogen. Nitrogen is converted from atmospheric dinitrogen into ammonia, and 80% of that is applied on agricultural soils as a fertilizer. It's very important for plant growth, and some of our literature showed that, or stated that this might be the single biggest contribution to population growth because we were able to increase food production so much. So in this process, this nitrogen is applied on soils and then not all taken up by plants. Some of it runs off into waterways and ends up in oceans and seas such as the Baltic Sea, where it leads to eutrophication, hypoxic areas, and eventually dead zones where no life exists anymore. So how did it intersect with the different SPs? Well, first it's important to understand that this boundary has been severely transgressed, and the point at which it intersects with an SP can be understood as, for example, at the driver level. So where is this nitrogen applied? Well, at soils. So this substance which we produce in society is systematically increasing in the biosphere at the point of application to agricultural soils. So there's a first intersection with SP2 at a driver level. Now, because the end impact of this process also systematically degrades marine environments, a second impact intersection was found with SP3. So this is the first example of how we ended up categorizing our intersections both as drivers as well as impact intersections. Now, a next example is a land system change. Land system change is the conversion of original forest cover to arable land, such as pasture and cropland. And this is a typical example of a systematic physical degradation of the biosphere by changing biodiverse areas into often monoculture agricultural production, physically degrades the biosphere, and therefore a primary intersection is with SP3, both on the driver as well as the impact level, because that happens at the same time. The degradation happens immediately at the point of conversion. In this process of conversion, large CO2 emissions are also produced, so this contributes to climate change. And one can argue, or we argue, that the emissions from this process, currently 12% from global greenhouse gas emissions, are a substance that we produce as a society through this process, and therefore is a secondary driver violation and intersection with SP2. Now, there's a lot more information in this, and just to give you a little bit of insight into the interrelation between all these boundaries and principles, we developed a causal loop diagram, and I'll take you through one example. So within the biosphere, society puts a demand on agriculture to produce food. This then drives the process of land conversion, which then, and this here, which then loses biodiversity and changes the integrity of the biosphere, which then systematically undermines the ability for society to thrive within the biosphere. So there's a lot of different connections going on here, and this especially enabled us to understand the relationships among the boundaries as well as among the principles and between the different intersections. And we can give some more examples of that later in the Q&A if you have questions.
Okay. So moving on to our findings from the interviews, one of the intentions of our interviews was to validate the matrix. But another intention was to further explore this idea of additive values and what attributes one of the frameworks brings to the other and vice versa. So in organizing our results, we decided to apply the 5-level model, commonly referred to as the 5LF. So within the systems level, interviewees mentioned the significant attribute of planetary boundaries to actually quantify boundaries to our systems. Especially those interviewees who are used to these sustainability principles and understand the language that we cannot systematically increase or systematically degrade. They mentioned that they're often left with the question, yes, but where's the limit? And the planetary boundaries actually show you that yes, there are limits to this planet. With this, interviewees noted that the ability of the planetary boundaries to identify current environmental problems. Especially considering some people do not think about the problems associated with specific Earth systems, such as nitrogen or phosphorus. So in providing these, the boundary quantification attribute and the problem identification, the planetary boundaries provide further additive value to the sustainability principles by determining which Earth systems to prioritize. And our interviewees stated that the planetary boundaries point out where we have already gone too far and where we need to focus right now. Also, this inherently communicates urgency, and interviews noted that the planetary boundaries is a very powerful communicative tool, and some refer to it as a dashboard visual. However, it is extremely important to note that the sustainability principles also provide the value of problem identification and do so in more of a holistic approach than the planetary boundaries might be able to capture, and that was also stated by our interviewees. Moving on to the level of success, our interviewees noted that the sustainability principles provide additive value by providing a definition of sustainability. And they mentioned that the sustainability principles are able to provide hope and direction when facing especially transgressed boundaries in our current Earth system. On the strategic level, our interviewees noted that the planetary boundaries can become a pragmatic tool for transformation, providing targets and goals, as I've alluded to with the boundary quantification. Alternatively, our interviewees noted that the sustainability principles are an ideal principle-based approach, one which provides flexibility, creativity, and innovation when moving towards sustainable development. And several interviewees stated the advantage of applying the precautionary principle, especially when faced with unquantifiable boundaries, such as novel entities. Applying sustainability principles to the planetary boundaries is inherently precautionary and then arguably much safer.
Thank you. So an integrated approach of sort of using the best of both would give us an enhanced systems understanding. So being able to use the power of an SP analysis with the urgency indicators of the planetary boundaries would give us both insights into what do we really need to address right now as humanity, at the same time also know where those boundaries are. So we found that through combining them, we are able to learn more about the system and in that sense have a better understanding. And again, it's very important that a further analysis is done beyond these boundaries, because even though these boundaries are prescriptive, they are not holistic and may not cover all issues. What especially helped us was to be able to distinguish drivers and impacts in order to understand the relationships and the complexity of these issues. From that, we could move on to the next level. So if we were to integrate a definition of success from both frameworks, which one could imply from the idea of the safe operating space, as well as the clear definition of success by the principles, we could merge them to come up with this figure, where society is internally governed by the social sustainability principles, and any of our interaction with the biosphere is governed through the three ecological principles. Now, that biosphere is stable if it is within certain boundaries that have been identified by the planetary boundaries. And then these arrows suggest the primary intersections that we found. So this both gives us a timely understanding of sustainability, as well as the flexibility to govern the transformation, as well as the final sort of sustainable state by integrating the best of both into this figure.
So if we move on further in strategy and consider the intersections that was just spoken to between the planetary boundaries and the sustainability principles, and how they intersect and provide additive value, and also in understanding the system and the definition of success, as Nicole and Pieter just alluded to, then we can use them, practitioners can use the integrated approach to inform appropriate strategic guidelines for how we can move from an unsustainable state to a desired sustainable state, so a definition of success in that way. What's really interesting on this context is that we can operationalize the SPs to bring transgressed boundaries back within the safe space, which is a bit of what Johan Rockström talked about in the video. And furthermore, we'll also talk a bit about what sort of governance is then necessary to steward that safe space once we've arrived back in there, which we hopefully will. And then just to note that the curves that will be in these are not based on any variables, but they're depicting a scenario just to kind of illustrate the point that we're trying to make here. And those little arrows you see at the end of each boundary just means the red one's going up, means that the boundary is pushed beyond or pushed towards the boundary. The one going down for stratospheric ozone is systematically decreasing already, and that's the only boundary that's actually doing that right now, I think following the Montreal Protocol. So what's interesting here with this one is that for boundaries that are still within the safe operating space, governance by SPs is sufficient to make sure they stay there. So if we apply the sustainability principles to a boundary that is not above the boundary yet, that will flatline or stabilize the negative trajectory in that space. Most likely also resulting in a systematic decrease over time, but still within that safe space. So if we do that, we would inherently be safe. Within boundaries that, like novel entities and aerosol loading, that have not yet been quantified, it's hard to conclude anything there, but as a minimum, we would say that governance by SPs should always be employed. If we move on, it becomes a little bit more complex with some of the other boundary transgressions. For some, such as nitrogen and phosphorus and biosphere integrity, governance by SPs is sufficient to bring them to govern that journey from where we currently are back into the safe space, as if we cease the emission or emitting or releasing nitrogen and phosphorus, for example, through agricultural application, that will result in an immediate beginning of a systematic decrease that will take us back within the safe operating space relatively quickly. The same goes for biosphere integrity. Obviously, we can't bring back species that have gone extinct, but we can bring, or we can level the rate, the extinction rate, and bring that rate back into the safe operating space. So make sure that we don't, that we are governing that boundary and not increase the extinctions. However, with land system change and climate change, the scenario is a little bit different. Land system change, we are currently at 62% of original global forest cover. We need to be at least 75. We've kind of already stolen that land in that way. So if we simply try to bring that boundary back within the safe operating space just using the SPs, it will get back there eventually, but it will take a long time because the land we've already stolen will not get back. So we need to actively induce a systematic decrease by human activity. The same goes for climate change because CO2 takes approximately 1,000 years to dissipate once released into the atmosphere. So by ceasing emissions, they'll be great, yes, but we still linger within the zone of uncertainty, and just by using the SPs, we will stay there for potentially hundreds of years, which is obviously not ideal either if we are to bring it back within, say, 2 to 3 decades, as Johan Rushton talked about. So to sum that up in a way, there's a little visual here that we can just kind of speak to the journey back into the safe space for the boundaries that have been transgressed. So for genetic diversity, SP3 will bring us back. The same goes for nitrogen and phosphorus. SP adherence will take us back in there within the time frame that we need to do. With climate change, SP1, SP2, and SP3 plus active measures to sequester carbon. And for for land system change, SP3 plus active measures to restore. And then it's super important here to say that then once we're back within the safe operating space, we can apply SP1, 2, and 3 to govern that space to make sure that we remain there. And that's where they become operationalized once again in that. And then also really important to know that for any unquantified boundaries, as well as areas that are not covered by the planetary boundaries, SPs of course should be applied here. And getting the planetary boundaries back within the safe operating space is a massive step, but it does not cover the full spectrum of sustainability. So it's also important that you don't rest in that success, but keep a holistic picture. So to sum up what we've done here, we had an invitation from the field, and we chose to say a challenge accepted. And then through answering our research question, we've tried to identify how the SPs and the planetary boundaries, they do intersect and add additive value. And we think there is indeed a potential for integration, and which also enhances their operational strength. In terms of contribution that we think that we've brought to this discussion, that, or at least alluded to, is that on the system level, there is an enhanced understanding of the conceptualization of all this, and by also developing the matrix and the complex loops to kind of visualize the drivers, the more three-dimensional ways of looking at it. On the success level, like an enhanced conceptualization of the sustainable state by integrating both frameworks, and on the strategic level by the approaches I just alluded to in terms of how we can guide that journey back into the safe operating space. In terms of moving forward, this was a theoretical step towards this. So a logical next step would be for someone to grab this work and some of the stuff that we've now presented and test it in practice. Do a few iterative loops of throwing it out there. Another way would be to test it and apply it on different systems. Like we have an assumption, at least within the research team, that this could also work on systems such as transportation or energy, for example, with altering minor things in there. It would be fantastic if we could look at an increased way of integrating the social principles and social sustainability in this. We found it hard within the matrix, but there is an inherent potential and obviously a massive influence and interrelationship between those two systems. So that would be also a good area for further research. And then finally looking into potential ways of modeling or software to play around with how we can feed these quantified boundaries, principles into developing maybe scenarios or ways that can also further inform strategic planning or strategic guidelines to move us towards a more sustainable state. So all in all, that was what we chose to present to you here. There was more in the thesis, but we think this was a good highlight of what we've been presenting. So thank you for your attention.